All right, in this video, we're going to add one new linear equation form. We're going to add point-slope form. So you can see slope-intercept form is here, which we have previously talked about. We're adding in point-slope form, which we're going to jump to this other question. When do we use point-slope form? So this is like the most obvious question I've asked all year. We're going to use it when you are given a point and a slope. So if you're given the slope of a line and you're given a point that the line goes through, you're going to use this. And that's because you can see the point slope form is outlined right here. Again, pause the video as needed here to copy everything down. Of course, M is the slope. And then the x1, y1, that represents a point on the line. So it'd be like if we drew a line. Of course, the slope is just the steepness of the line. And then the point, x1, y1, can be any one of those points along the line. So all you need is the slope, the steepness of the line, and one point that line goes through. And you can graph a function using point-slope form. So let's go through one example together, and you'll do one on your own. So first off, notice the directions. Say they want us first to write an equation in point-slope form. So we're going to write that form of the line first for both of these examples. And then second, we're going to write the equation in slope-intercept form. And then finally, third, we're actually going to graph the function. All right, so let's look at example one. They give us a point and the slope. The slope is 3.5, and then the point that's on the line is negative 3.2. So we're going to rewrite this equation in point-slope form. So it's going to be y, hold on 1 second. First, let's label the numbers. 3.5 would be the m, because that's the slope. Negative 3 is the x1, and then positive 2 is the y1. So we're just going to take those numbers and insert them into point-slope form. The one tricky part is, remember, the form has subtraction signs, so we are subtracting, but the x1 coordinate is a negative 3. So of course, when you subtract a negative like that, it becomes x plus 3. So that's it. That is point-slope form of the line. That's what's new here. So that's the first part. Now we're going to do the second part, and we're going to rewrite this in slope-intercept form, which basically just means we need to solve this for y. So we're going to distribute the 3.5 to both of those terms. So I'm going to rewrite this problem as y minus 2. 3.5 multiplied by x is just 3.5 times x, and then 3.5 times positive 3. For this, I am going to pull out the calculator. So 3.5 times positive 3 is 10.5. So we just distributed the 3.5. And then finally, we want to solve for y, so that means we need to get y by itself. So we're going to add 2 to both sides. And now y is going to be isolated on the left-hand side. On the right-hand side, we're going to have 3.5x plus 12.5. So this is the slope-intercept form of the line. For now, we are not going to graph. We're just going to focus on rewriting the equation in both of these forms. Strongly encourage, pause the video and try the your turn on your own. I'll show you some of the steps here in just a few seconds. So I encourage you to pause the video and see if you can do it on your own first. So again, your first step is figure out what m, x1, and y1 are. I'm going to show the next step here in just a couple of seconds. So again, feel free to pause if you need to. So there's the answer for point slope form. And then here in just a few seconds, I'm going to write the answer in slope intercept form. So distribute the -2 as your first step. Pause the video if you'd like to try it on your own first. And then there's the answer in slope intercept.